Okay, so there's two more concepts before we move on to the algebraic view of vectors. Remember, we start off with vectors saying that they're arrows, and then we learn how to add arrows and subtract arrows and also scale, multiply, or just scale for short, scale the arrows. So they're all done geometrically, right? But there's an algebraic way of doing that. And before we move on to that, we just want to also introduce a couple of new notations and also a new concept, a new term called unit vector, which is very simple, but let's just get it out of the way. So first of all, remember vectors have magnitude and direction, right? So if I have a vector like this, right? So let's call this x, right? This is the vector x. And remember the vector notation. Notation is just a fancy way of saying the symbol. We're good at physicists are good at inventing new words to confuse people. Right? So that's what notation means. And so whenever if you are describing a vector, you put a little half arrow on top. And remember, in textbooks, you probably have seen that already. It's very difficult to type this little hat vector, right? It's not impossible, but it's just annoying. So the convention is that in textbooks, people would just make it bold, right? So either bold, but of course, making things bold is very difficult to write on paper or on the board. So when you write it, handwriting things, you put a little half arrow there. Okay. Let's say this is 5 units long. Let's say like this, right? So there's a way to say just the magnitude or the length, right? The length and magnitude is this. I will use it interchangeably. It'll make more sense when you apply that to real life scenarios like physics. But at the moment, just treat that as the length, right? And when I want to say instead of saying the length of or the magnitude of x vector equals to 5, we invent a symbol for this, and that's like the absolute value sign, right? So you put 2 strikes like this, that means the length or the magnitude, right? So you can just write this, and that's it. Now there's a lazy notation for this, so there's another lazier way. Is if you use x vector to describe the actual vector, then you can just write without the vector, that's the magnitude, right? So without the vector sign, that's basically identical. This symbol means identical to this. Okay, so this is another way to write it with just without the little vector on top. This good and bad. Obviously, the bad is it's confusing sometimes because this could be determining a number. It does make sense because 5 is a number, right? 5 is a scalar. It's not a vector. It's not an arrow. So in some sense, in some way, it makes sense. But sometimes it could be confusing. Okay, right? But just let you know, I might use either way, either of them as we go on. Okay. Okay, good. So this brings us to the concept of what's a unit vector. A unit vector, again, is very simple. As you can guess, it's a vector with a length of 1 unit. All right. So it's a unit vector or length of 1 unit. So if this is x, right, of 5 units, then I can make a unit vector out of this. Let's see if I can make it 1, 2, 3, 1, 2, 3, 4, 5. Not very well spread, but let's work with that. Then this little bit, right, just that length over here would be a unit vector, all right? So we can give it a different name. We can call it u or something, but if this is a unit vector, it is conventional that we use this symbol. We put a little hat on top. So anytime you see a vector, whether it's, if you see someone write this, or this, or this, or this, right? If there's a hat on top, it's emphasizing that this is a vector, not only a vector, but it's a vector with 1 unit. Whether your frame of reference is each unit is a centimeter or a meter or kilometer, it's 1 of whatever the unit you're talking about is. Okay. All right. So here's a formula for you that could that it can be confusing. Is the unit vector is actually the same as the vector divided by its magnitude. Now this looks scary. I'll put it in a box, but if you think about it, it makes perfect sense because this guy has a direction. This guy sorry, this guy have a magnitude of, let's say, 5, right? So if what that means is the magnitude of it is 5, so I can write it as 1/5 times. So I'll not write the times, I'll just write it like this. Okay, so this guy has a magnitude of 5, but if you divide it by 5, then you're going to get a vector that is pointing in the same direction with a magnitude of 1, right? So you can create a, you can relate the unit vector of a vector by dividing by its magnitude, okay? So just to summarize that, the unit vector of x, this is the x vector and the magnitude of x vector, okay? So let me repeat that one more time. If you take the vector and divide by its magnitude, you get a unit vector, okay? Another way of thinking about it is vector only consists of, put that here, just not to confuse you. Vectors only consist of a magnitude and a direction, right? So if you multiply something in front, remember, if we talked about scaling it, right? So if x looks like this, 2x is just this times this, like this, sorry, this plus this. So if you multiply by a scalar, so that's why it's called scale multiply, right? Multiply by a scalar, it still points in the same direction, right? So if you multiply by a fraction like 1/2, well, that just means you, instead of stretching it by 2, you half it, right? So now that, right, if I delete that, right, so that would be half of x vector, like this. Now, if the original length of x is 5 and you divide it by 5, you basically shrink this all the way back down to a length of 1. And of course, you get the unit vector. All right. So hopefully that makes sense. And there are a couple of famous unit vectors, and they're called base vectors. Okay, so this is the last jargon you want to learn, base vectors. That means, so what that is it's called I, J, K, right? So these are obviously unit vectors, but they are unit vectors along specific directions. They're specifically along the x-axis, y-axis, and z-axis. So if I draw a x, y, z like this, by the way, when you draw 3-dimensional coordinates, this is usually the way to draw it. So sort of having y and z here, and then x sort of points out of the board, sort of at an angle like this, right? So the I hat is the unit vector that is of 1 unit, of course, pointing along the x direction, okay? So everyone uses this symbol, I hat, to point this way, and everyone uses j hat. It's a vector or an arrow with 1 unit of length pointing in the y direction, and k hat this way. We live in a 3D world, so these are very useful sort of building block vectors, right? So in 2 dimensions, sometimes we're just interested in 2 dimension, then you don't need the k. It's only relevant to talk about sort of, oops, only relevant to talk about this I hat and j hat like that. Okay, so these are base vectors, and together they're sometimes called the bases, right? So with this in mind, we'll now go and look at how do we build up an algebraic way to deal with these arrows. Okay.